This is question 3 from the mock test. Just a note on question 2, one of the questions it asked is about banked corners, so be sure, it was on a quiz, so make sure you study that. But 3 says, question 3 has a planet, so let's just draw this picture. Yeah, we got a planet, and this guy is here we go. Here's the planet, 3.78 times 10 to the 25th kilograms. Here's the moon moving around it. And this is 5.89, not to be confused with 5.98 times 10 to the 22nd, right? And then this distance, the center to center distance is 4.9 times 10 to the 8th meters, right? And the first question is, what is the force of gravity between these? And if you've got this piece of paper at home and it hasn't been corrected, the answer on my sheet says 6.19 times 10 to the 29th. That's incorrect. It's times 10 to the 20th. Okay, but that's only a problem of a factor of a billion, so that's pretty close, right? So the first one is, what is the force of gravity? I'm going to use F as gmm over r squared, right? And this guy is always going to be 6.67 Newton meters squared per kilogram squared, right? So this force is going to be for A, 6.67 Newton squared per kilogram squared, right? Okay, times 3.78. And by E, I mean times 10 to the, right? And then 5.89. E22, and I'm divided by 4.9 E8, okay? Now literally I'm going to type this into my calculator, 6.67 E minus 11, that's got to be the unary minus, the little bitty minus, right? Times 3.78 E25 times 5.89 E22 divided by 4.9 E8 squared, right? And you can do that. You can just say squared and it'll work. All right, 6.67 E times 3.78 E25 times 5.89 E22 divided by 4.9 E8 squared. And indeed, it's the answer I get here is 0.185 times 10 to the 20th newtons. Yay, right? And then it says, what is the orbital speed of the moon, right? And that's part B. For the orbital speed, I'm going to say G, mass of the planet, mass of the moon, over r squared is mass of the moon, and then v squared over r, right? It's the moon's mass that's going to cancel. You've got two masses here. This is the one that stays behind in the formulas, okay? And so I guess we're going to solve this for v, right? So r goes away, and we can just square root, right? It's going to be the square root of g, mass of the planet, over r. Right, so that's going to be literally in my calculator. I'm going to type square root left parentheses 6.67 E minus 11, right, times 3.78 E25. Remember, I've got to use this mass. The satellite mass is the one that canceled. That's the guy that's gone right here, right? And then I'm going to divide by 4.9 E8. So square root 6.67 E minus 11 times 3.78 E 25 divided by 4.9 E8. And I'm getting that it's 2268.35. Is that the right answer? Yay. Okay, and then what is the acceleration of the moon? There's two ways to do this. I could go A is v squared over r, right, and go 2268 0.35 squared divided by 4.9 E8, right, meters. And that's going to give me some answer, right? The other thing I can do is just use F equals MA, right? I've got the force. Here's the force, right? So I'm going to do that 6.185 times 10 to the 20th equals, where's the moon's mass? 5.89. 10 to the 22nd times A, right? So F, this is newtons, equals MA. So 6.185 E20 divided by 5.89 E22. A is 0.0105. Right. This will also work. So square that divided by 4.9 E8. Same exact answer, right? Because the force is causing that acceleration, right? Do we have questions? Do you guys have questions about number 3? And on page 3, actually page 3 is the one that's on Duggan's little thing. So it's the other problem. The other ones that aren't on there is what's the force of gravity between a bowling ball and a person. But that was on the pre-quiz or the little thing yesterday. It's also on the review site for the test. I solved that one last time. And then the spinning a bucket upside down is on there. The entire page with just different numbers is on that Duggan thing. So, alrighty. No laughing.